mapping, main memory, it is given that it is 16 bits address. The main memory consists of 16-bit address. Okay, so 16 bits, the same 16-bit address is there, so it has 2 power 16 words. Okay, and each block has 16 words. Okay, that is 2 power 4. 2 power 4 words are there. Fine, so this is given, and also the cache blocks. So this is the cache block, and these are the details given with for the cache block. That is, it consists of 256 blocks. It contains 256 blocks, and each block of 16 words. Okay, each block is of 16 words. Now the question which is asked is, we are seeing for associative mapping. Associative mapping consists of 2 fields. Okay, word and tag number. Okay, all of you know how to calculate the number of bits for the word. Okay, how many words are there in each block? In each block, how many words are there? It is shown here. There are 16 words. Okay, so that is 16 is 2 power 4. Fine, 2 power 4 means 4 bits are required to represent the words. Okay, to represent the word means 16. In particular block or a game, there are 16 words. Okay, to identify which word it is. Okay, 16 means 2 power 4. To identify which word it is, I need 4 bits. Okay, so 4 bits for identifying the word. Now coming for tag number, it is total number of bits for the address minus word bits. Okay, how many bits are required for the address? How will I know how many bits are required for the address? So main memory, how many bits are required for the address? It is given. It is 16 bits for the address. Okay, so 16 minus 4 is 12. I had told that cache address or main memory address, it is same size and it is same bit pattern 10101. So same bit pattern is for cache memory also. Okay, yeah, NA pattern new tagondru. Suppose I consider this as the main memory address. Okay, the same address is mapped to the cache memory also. Now here I have taken 8 plus 8, 16. Okay, so first least significant 4 bits represent the word, remaining 12 bits represent the tag number. Okay, so a total number of bits minus word is 12. So that is tag number. Okay, so there is no particular like how to map the tag number. How do I get the tag number? Anta whatever is the remaining address for that particular block in main memory, that is the tag number which is stored for each block. It can be with respect to the main memory, whatever is the address for each block, that will be the tag number. There is no particular pattern here. Okay, and that's why the operating system has to search all the tag numbers. Whenever I want to, I'm searching for a particular block, it has to search all the tags. Okay, now we'll see. Okay, fine. Students, you can copy down. I'll send 2 questions. Okay, for the associative mapping. 2 questions will be sent, and I'll send this PPT also. Okay, you can just find out what is the associative mapping for the 2 different next problems, whatever I send. Okay, so simple, find the address length, how many bits are there for representing the address, how many bits are required for main memory, find that, and find the number of words, number of bits required for representing the words. Okay, so number of bits for the address minus number of bits for the word gives the number of bits for tag number. That's all. Okay, so that is associative mapping. In associative mapping, there is no restriction. A particular block should go to that block only of cache memory. Like that, there is no restriction. Any block which is free can be mapped to the any block which is free. The block can be placed in that particular cache block. Okay, fine. Next, we'll see the set associative mapping. Okay, so set associative mapping is a combination of direct mapping and associative mapping. Fine, it is a combination of direct mapping and associative mapping. So here, the how the block is mapped to a particular location is, I suppose I want to place block J. Okay, then it is block J modulus cache set. Cache set means the cache memory is divided into number of sets. Okay, how it is divided is, suppose here in this diagram, in this particular example, it is 2 blocks in one set. Okay, 2 blocks in one set. So the advantage of this associative mapping is there is only small restriction. Direct mapping tara full restriction illa. A block should be placed on a particular block only. Like it, that is the restriction in direct mapping. Whereas in associative mapping, you had seen that there is no restriction at all. Okay, it is this particular algorithm technique is very free, means any block you can place. This is full restriction, correct? Whereas set associative is a combination of those two. So how the combination is done is, the block can be placed in any set. Okay, in this particular set, this block can be placed in any of these two sets, any of these two blocks. Okay, only set mapping ge matra restriction ide. Within this set, it can choose any block, whichever is free. Okay, or choose any block. Okay, and so it is, there is no full restriction in set associative mapping. It is a combination of direct mapping and associative mapping. So the name set associative, you have seen what is set here. Number of blocks is grouped together to form a set. Okay, this particular example is two-way set associative. Okay, two-way set associative means 2 blocks are grouped to form a set. And we say generally it is k-way set associative technique. Okay, k-way means k can be any number. If k value is 3, means 3 blocks are grouped together to form a set. If k value is 4, 4-way set associative means 4 blocks are grouped together to form a set. Okay, so the cache memory is grouped into sets. Fine, cache memory is grouped into sets, and out of this one particular block is mapped to a set. Okay, so in this set it can choose any block. Okay, it can choose either 126 or 127, any one block. Fine, so for mapping to the set there is restriction, but within the set there is no restriction. Fine, so that is set associative, combination of direct and associative mapping. Here it is the technique of direct mapping which is used, that is block J 63 modulus cache set. How many sets are there for the cache? Okay, so cache set will give the location. So that is the technique of direct mapping. So within this particular set, the technique used is associative mapping. That is, any block within the set can be used. Fine, understood, student? Set associative is a combination of direct and associative mapping. Now, what is set? I have told set is a group of blocks, form a group of blocks in cache forms a set. Okay, now as per this example, there are 128 blocks. Fine. And 128 blocks are grouped, like that is 2 blocks forms one set. 2 blocks forms one set. Okay. So how many sets are there in cache memory? Number of sets. Can anyone tell me how many sets are there in cache memory? Total number of sets. So this is set 1, this is set 2. 128 total blocks in there. Okay, it is grouped into 2. So how many total sets are there? That is 2 blocks forms one set. 128 blocks forms how many sets? Can anyone tell me how many sets in cache block, this particular example?
Ma'am.
64. There are 64 sets. Okay. So the cache memory of 128 is divided into 64 sets. Fine. Now, if I try to place this block 63, so the technique used is 63 modulus, okay, number of cache blocks. 63 modulus cache set. Cache set is 64. 64 sets are there. It is nothing but 63. Okay. Cache set 63 is last. Okay. This is set 63. This is set 0. Start from 0. This is set 1. And this last set is set 63. So you can observe the color. The last, the 63 is mapped to these 2 blocks of the set 63. And block 63 will be present in block 126 or 127. Okay. So that is set associative mapping. Cache memory is grouped into sets. Okay. Each set will have number of blocks. Okay. So the main memory is mapped to the set by using this technique, that is percentage block J. If I want to place block J modulus number of cache sets, how many of our cache sets are there? Okay. After selecting the cache set, it can be placed in any block of that particular set. Fine. Any doubts, students? Before going to the address, how the address is got, we'll just discuss if there is any doubts. Any doubts? Okay. So can anyone tell me what is the memory, how many bits are there for this memory address? Okay, the same example I have taken. There are 4096 blocks. Okay, each block containing 16 words. Okay, that is nothing but 4 into 1024 into 16 words. That is 2 power 2 into 2 power 10 into 2 power 4. Okay, that is nothing but 2 power 16. So 16 bytes are required for representing this addresses. Okay, so it consists of main memory address consists of 16 bits. Okay, 16, not 16 bytes, it is 16 bits. 16 bits are required for representing any memory, any word location of a particular block. Okay, now how the 16 bits are divided, coming to cache memory, how the 16 bit, what each represents, that is what we are seeing here. So the least significant 4 bits are for the word, that is each block contain 16 words. Okay, that is what the example we have taken, 16 words. 16 word is nothing but 2 power 4. So word contains 4 bits. And how many sets are there? We had seen totally there is 128 divided by 2. It is grouped into 2. sets. Okay, that is 64 sets are there. Correct, there are 64 sets. How it is, how do I know that it is 64 sets? How do I know it is 64 sets? So in each set there are 2 blocks. So in one set there are 2 blocks. Okay, what was I do? So 2 blocks in one set, 128 blocks in how many sets? That is, how many sets are there like this totally? Okay, that is 128 divided by 2. It is nothing but 64. 64 is nothing but 2 power 6. Okay, so 6 bits are needed to represent the set. Fine. And to find the tag number, you can always do 16 minus 6 plus 4. Okay, 16 minus 6 plus 4 is nothing but 6 bits. Okay. So, yes. So this is the structure of the address bit division in to the cache memory in set associative mapping. Okay. Blocks are grouped into cache, into blocks of cache memory are grouped into sets. Okay, and specific set contains, that is a number of blocks. How many blocks does it contain? That is the set associative. Means if a set contains 4 blocks, okay, block 0, block 1, block 2 and block 3, if it contains 4 blocks, then it is told as 4-way set associative mapping. Fine. So okay, fine. So to find the number of sets, it is Jagdish, I'm in class. So number of sets in caches, total number of blocks divided by, okay, total number of blocks divided by the number of blocks in set. Okay, that is to find the number of sets. And to find the number of tags, always you can, the simple thing is total bits for address minus word and set. Okay, number of bits for word and number of bits for set. Okay, that is the simplest way. So you can do it that way. Fine. Now we'll see the same problem for the mapping of set associative mapping. Okay, so set associative mapping, it is it is not given what is the, how many blocks are there in a particular set. So we have to just assume there are 2 blocks, cache blocks in one set. Okay, it is a simple 2 cache blocks in one set, means the calculation also is simple. Okay, so it is how many word bits are there, how many sets are there, and how many bits for the tag number. Okay, so it is number of words is 16, so 2 power 4, 4 bits are required for representing the words. And coming to number of sets, I have assumed it is 2 blocks in one set. Okay, total number of blocks is 256. 2 blocks are there in one set, so divide by 2, and hence there are 128 sets for this cache memory. Okay, so 128 is nothing but 2 power 7, so 7 bits are required for representing the set. Coming to tag number, so tag number you can always do like this, that is number of address bits is 16. From here you can get it as 16 minus 4 plus 7. Okay, 4 plus 7 is 11. So it consists of 5 bits. Okay. Or one more thing, one more way what you can do here is number of tags is number of main memory blocks, that is 2 power 12 blocks are there. Okay. And number of cache sets. Sets is 2 power 7 number of cache sets. Okay, that way also you can do. Fine. One more example I have not taken. Okay, so I think you can do one more example. 1 second. Okay. Fine. We had taken one more example in the previous problem. Okay, so it is, okay, we'll do it for set associative mapping. So it is given that 64 blocks So we'll solve this for set associative mapping. Okay. So cache memory consists of 64 blocks. Okay. It consists of 64 blocks, and it is the main memory is 4096 blocks, 4096 blocks of 128 words. Okay. So 128 words are there. You can easily find the number of bits for memory address. Okay, same as we had done yesterday. So 2 power 12 blocks and 2 power 7 words. Okay, there are 2 power 7 words in each block. Fine. Now I should find how many for set associative. Okay, here in this question also there is no number of blocks in in a set. So you should assume that there are 2 blocks in one set. Okay, in a set, 2 blocks in a set. Fine. And the division of memory is like this. That is, there I have to find word bits. I should find how many bits for representing the set, and I should also find the tag bit. Okay, how many bits required for the tag. Now how do I find the word bit? How many words are there in one block? Number of words. How many words in one block? What is given? How many words are there in one block?
128.
There are 128 words. 128 is nothing but 2 power 7. So 7 bits are required for representing the word. Okay, word. 7 bits are required. Now, number of bits required for the set field. The next field. So how do I find the number of bits required for the set field? I have assumed that each 2 blocks are grouped into one set. Okay. And the total number of blocks in cache memory is 64. Fine. 64 divided by 2 is nothing but 32, which is nothing but 2 power 5. So 5 bits are required for representing the sets. Okay, 5 bits for representing the set. And for representing the tag, how do I find for representing tag, how many bits are required? Total number of bits for representing the address is 19. So 19 minus 5 and 7. 19 minus 5 plus 7 is 12. And here it is 7 bits. Correct?
Yes, ma'am.
7 bits for representing the tag. 7 bits for representing the tag. Fine. Or one more way for finding the tag, you can do any one. Fine. So number of cache main memory blocks is 2 power 12. 2 power 12. Number of sets in cache. how many sets are there? There are 2 power 5 sets. So 2 power 5, you get 2 power 7, 12 minus 5 is 7. So 7 bits are required for representing the tag bits. Okay, I need 7 bits. Fine. So this is the final diagram. 757. Okay, this is set associative mapping. Okay, only thing here is the cache memory is grouped into, the blocks of cache memory are grouped into sets. Okay, so it is, what is the advantage of this particular mapping is it is a combination of both direct and associative mapping. Okay, so it has some restrictions of direct mapping and it is free like associative mapping also. Restriction is that it has to be mapped, the memory block has to be mapped to a particular set only, and it is free to select any block in within the set. Okay, so that is the set associative mapping. And you can whenever the explanation is asked in the exam, they can just explain set associative mapping with an example. So you have to take your own example. Fine. Or they can give such problems and ask you to solve. Okay. Any doubts? Any doubts, students? You have seen 3 ways of mapping: direct mapping, associative, and set associative mapping. Any doubts here? Okay, I'll just tell what is next topic, that is replacement algorithm, a small topic. Okay, all of you know what is replacement algorithm. I have told you. So replacement is, if suppose the cache memory is full, there is no free cache block. There is no free cache block. Okay, in direct mapping, what happens? I directly know which is the block where I have to place the main memory block. Okay, so main memory, which block I should place this particular block 17. I know it directly. So this is direct mapping, and there is no need for replacement algorithm. So if it is associative mapping, what happens? I can place it in any block of cache memory. Suppose the cache memory is not free, all the blocks are full, then I have to select a victim block from this. Any one block can be selected. So how to select the victim block is by using replacement algorithm. Some of the examples are like this: first in, first out. Whichever block was filled first, any block which was filled first, that will be selected as a victim block. Or least recently used. Okay, that is the block which is not used since a long time. Okay, I'm not at all, the operating system, the processor is not at all requesting that block instructions. Okay, least recently used. So such a block which is not used for since a long time, such a block can be selected as a victim page. So that is the victim block. Okay, that is replacement algorithm, by using replacement algorithm. Fine. The operating system can directly select any block, but it might be being used, or it might be used very frequently. Okay, such blocks are there, and hence these algorithms are there. Any one of the algorithm will be implemented in the operating system when it is built. Okay, so that is about replacement algorithm. Fine. So we'll see the last topic in the next 2 classes, and that will finish the 3rd module. Okay. So before ending, you can just ask if you have any doubts.